As a component of mechanical equipment, seamless tube is stronger and therefore more resistant to pressure and tension than a tube with a welded seam. That's because seamless tube is made from a solid bar of stainless steel, rather than from a strip that's rolled and welded into a tube. Seamless stainless steel tube is used when reliability is critical. For example, in aerospace engines, nuclear equipment, and medical devices. A manufacturer purchases stainless steel tubes in a range of lengths, diameters, and thicknesses. The engineers select the right starting size for the specific tube the customer has ordered. Each one is checked with a tape measure, and then a large micrometer to measure the outside diameter. Engineers switch to a smaller micrometer to measure the wall thickness. They're then weighed. If the raw material meets all the specifications, production can begin. The team insert one end of each tube into this rotary swedger. It shapes the end to a point to enable it to fit through a die with a smaller diameter. Operatives spread lubricant onto a steel bar. Insert it into the other end of the tube. Then insert the pointed end through a draw die. This carriage then grabs the protruding point and draws the full length of the tube through the die and over the steel bar. The die reduces the tube to a smaller outside diameter, while the bar sets the desired inside diameter. The tube walls thin out, and the tube elongates in the process. The next machine's two rollers apply pressure to the outside of the tube as it passes. This expands the tube slightly, creating a slight gap between the tube walls and the bar inside. This enables the next machine to extract the bar. Finally, the point is cut off the end of the tube. The team place several tubes at a time in a degreasing unit, which uses a cleaning solution to remove all traces of lubricant the tubes picked up during the draw process. Operatives then transfer the tubes to drying tanks, positioning them at a slight downward angle. As air blows through the tubes for about half an hour, all of the cleaning solution either drains or evaporates. To further clean the inside of the tubes, operatives insert a felt wad into each one, then squirt in some cleaning solvent. They blast in compressed air to force the wad down the tube. As the wad travels the length of the tube, it wipes the inside wall with the cleaning solvent. Next, operatives strap the tubes to a belt that takes them on a 30-minute trip through a furnace. The temperature inside is more than 1000 degrees Celsius. This intense heat softens the steel, which is hardened as a result of having been pulled through the draw die earlier. This process is called annealing, and it slightly warps the tubes. So next, they're passed through a straightening machine. Then the entire cycle repeats until the tube is reduced to precisely the diameter and wall thickness the customer ordered. The finished tube can be up to 40 times longer than its original starting length. To ensure the structural integrity of each tube, an electrical current is run around the circumference. A break in the current indicates a defect, which engineers then cut out with a saw before cutting the tube into the lengths the customer ordered. The saw cuts leave burrs or rough edges, so the cut ends are inserted into a deburring machine, which grinds the edges smooth. The last step is to submerge the tubes in an acid solution to remove any iron particles picked up from the processing. This prevents the tubes from rusting. What they're left with is a perfectly formed seamless tube ready to withstand the rigorous use that a normal seam tube would never be able to cope with. And sadly, it would seem it's the end of the show.